Dear students, in this lecture we will discuss about Fourier series for the interval c less than equal to x less than equal to c plus 2l. Examples of this interval. We have a problem. Find the Fourier series, Fourier expansion for the function fx is equal to x minus x square in the interval minus 1 less than x less than plus 1. Okay. Here by the Fourier series for this such type of interval, here we have c equal to minus l. Okay. That is, we know that fx is equal to x minus x square is equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x upon l plus summation n equal to 1 to infinity bn sin n pi x upon l. Okay. Here in this interval, if we compare this with c less than equal to x less than c plus 2l, here value of c is minus 1. That is, value of c is minus 1. Okay. Now we compare this, we get l equal to 1. If we compare this, minus l less than x less than plus l, here value of l is 1. Okay. What we have? We have fx is equal to x minus x square a0 by 2 plus summation n equal to 1 to infinity an cos n pi x plus summation n equal to 1 to infinity bn sin n pi x, and this is the equation number 1. Here l is equal to 1. In this interval, when we compare this minus l less than x less than plus l, here l is equal to minus 1. Okay. Now we put here l equal to minus 1 here. Now what is the value of a0? Formula of a0 is 1 upon l minus l to plus l f of x dx, that is l is equal to 1 minus 1 to plus 1 fx. Fx is x minus x square dx. Okay. Now we apply this limit. Now first we integrate this. a0 equal to, here we have to find out three Euler's coefficient a0, an and bn. This is the formula for a0, and this is 1 upon 1, that is 1 into minus 1 to plus 1. Now we integrate this. 1 into integration of this x square by 2 minus x cube by 3, and limit is minus 1 to plus 1. First we apply upper limit. Upper limit is x equal to 1, that is 1 by 2 minus 1 by 3, minus lower limit. Lower limit is x equal to minus 1, that is 1 by 2 plus 1 by 3. That is a0 equal to 1 by 2 minus 1 by 3 minus 1 by 2 minus 1 by 3. These two cancel out, means a0 equal to minus 2 by 3. Now we find out next coefficient an. What is the formula for an? Formula of an is 1 upon L minus L2 plus L fx cos n pi x upon L dx. Okay, here L is equal to 1, means we have 1 upon 1 minus 1 2 plus 1. Fx means x minus x square, and here L equal to 1 means we have cos n pi x dx. Now we can divide this integration in two parts. Number 1, minus 1 to plus 1 x cos n pi x dx, and integration of minus 1 to plus 1 x square cos n pi x dx. Okay, now in first integration, here limit is minus a2 plus a, means minus L2 plus L, and if this function, now we check the function. Suppose this is the function. Okay, here x is an odd function and cos n pi x is an even function. When we put x equal to minus x, then here this is an odd function and this is an even function, means product of an odd function and an even function will be an odd function. Here we can directly put by the property of definite integration, this integration will be 0 minus. Now we have to integrate this. In this second integration, x square is an even function, cos n pi x is also an even function. Product of two even function will be an even function, and means if it is even function, means by the property of definite integration we can write it 2 times 0 to pi x square cos n pi x dx, because we know that integration of minus a2 plus a fx dx is equal to 0 if f minus x is equal to minus fx, and this is equal to 2 times 0 to a fx dx when f minus x is equal to plus fx. Okay, now we have to integrate this by parts, taking x square as the first function and cos n pi x as the second function. That is an is equal to minus 2. First function means x square, integration of second, integration of cos n pi x is sin n pi x, sin n pi x upon n pi, minus differentiation of first, integration of second, that is minus cos n pi x upon n square pi square, plus differentiation of first, that is 2, integration of second, minus sin n pi x upon n q pi q, and limit is 0 to 1. Here limit of this integration is 0 to 1. I repeat it. First function means x square, minus 2 is the common term, integration of cos n pi x is sin n pi x upon n pi, minus differentiation of first, minus alternate plus minus means minus 2x, integration of second, integration of this, integration of sin is minus cos, that is minus cos n pi x upon n square pi square, plus differentiation of first. Differentiation of first is, here differentiation of this is, what is the differentiation of this? Differentiation of this 2 and integration of this minus sine pi x upon n q pi q. Now we apply this limit, n equal to minus 2. Now we simplify these two sign, these two cancel out. Now first we apply upper limit. Upper limit is x equal to pi. When x equal to pi, we know that here we have sine n pi, and we know that sine n pi is equal to 0. That is, this term is 0, plus 2 into 1, when x equal to 1, 2 into 1 upon n square pi square, and cos n pi. Cos n pi is minus 1 to the power n, minus here we have sin n pi term, again this is 0, minus lower limit is x equal to 0, 0 into this 0, plus 0 into cos 0 means this is 0, and again here sin n pi, again this term is 0. On solving this, we get here an is equal to minus 2 into 2 upon n square pi square minus 1 to the power n, that is 4 upon n square pi square and minus 1 to the power n plus 1. Now we find out second Euler's coefficient Bn, and formula of Bn is 1 upon L minus L2 plus L fx sin n pi x upon L dx. Here we have L is equal to 1, that is 1 upon 1, and integration is minus 1 to plus 1, and fx is equal to x minus x square, and here L is equal to 1, here we have sin n pi x and dx. Okay, now we divide this integration in two parts, that is, number 1 is minus 1 to plus 1 x sin n pi x dx minus integration of minus 1 to plus 1 x square sin n pi x dx. Okay, now again here limit is minus a to plus a, and we can also apply this property. Here some terms may be 0 if function is an odd function. Okay, now let us see here, Bn is equal to x is an odd function, sin n pi x is also an odd function, and product of two odd function will be an even function, means this complete function is an even function, means when f minus x equal to fx, it will be 2 times 0 to 1 x into sin n pi x dx. Now see second integration. Here x square is an even function. When we put x equal to minus x, this will be an even function, and sin n pi x is an odd function, and product of n even function and n odd function will be an odd function, means this complete function is an odd function for the limit minus 1 to plus 1, and we know that by the property of definite integration, if the limit is minus a to a fx dx and function is an odd function, f minus x is equal to minus of fx, then value of this integral will be 0. Okay. Now, what we have? Vn equal to 2 times 0 to 1 x into sine n pi x dx. Now we have to integrate by parts, taking x as a first function and sine n pi x as a second function. That is Vn is equal to 2 times first function means x, integration of second, integration of sine is minus cos, that is minus cos n pi x upon n pi, minus differentiation of first, and integration of this term is sine n pi x upon n square pi square, and limit is 0 to 1. This minus plus. Now we apply the limit 2 times when x is equal to 1. When x equal to 1, it is minus 1 into cos n pi. Cos n pi is minus 1 to the power n upon n pi plus sin n pi. Sin n pi, here cos n pi, what is the value of cos n pi? Cos n pi is minus 1 to the power n. Okay. And sin n pi is 0 minus lower limit. When x equal to 0, 0 into this 0 plus sin 0 is 0. What we have? Bn is equal to 2 times minus 1 to the power n plus 1 upon n pi. That is two minus 1 to the power n plus 1 upon n pi. This is the value of Bn. Now by the Fourier series, now we have to expand this function x minus x square in this interval with the help of Fourier series. And now from equation 1 we know that that is x minus x square is equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x plus summation n equal to 1 to infinity bn sin n pi x. Now we substitute the values of a0, an and bn. Here value of a0 is minus 2 by 3, that is 1 by 2 into minus 2 by 3 plus summation n equal to 1 to infinity, and value of an is, we have calculated an is 4 upon n square pi square minus 1 to the power n plus 1 cos n pi x plus summation n equal to 1 to infinity bn, and value of bn is 2 times minus 1 to the power n plus 1 upon n pi sin n pi x. Now simplifying this, now we simplify this, that is x minus x square equal to, this 2 cancel out, minus 1 by 3 plus 4 upon pi square. Now we open this. When n equal to 1, it is minus 1 to the power 2 means plus 1, that is cos pi x upon 1 square. When n equal to 2, here we have negative term, cos 2 pi x upon 2 square. When n equal to 3, here we have cos 3 pi x upon 3 square, and so on. Plus, here common term is 2 upon pi is the common term. When we put n equal to 1, it is minus 1 to the power 2 means plus 1, that is sin pi x upon 1 minus sin 2 pi x upon 2 plus sin 3 pi x upon 3, and so on. And this is the final answer. Okay. Now we will take one more example for better understanding this kind of problems of this kind of intervals. Now we have another example. Suppose we have a problem. Find a Fourier series with period 3, to represent fx is equal to 2x minus x square in the range 0, 3. Two x minus x square. Okay. Here period p is equal to 2l. Here interval is in the form 0 to 2l form, and 2l is equal to 3, that is l is equal to 3 by 2. Okay. We have to find out Fourier series for the interval 0 to 3, means it is of the form 0 less than equal to x less than equal to less than 2l. Okay, means l equal to 3 by 2. Now by the Fourier series we know that fx is equal to 2x minus x square is equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x upon l. Here l equal to 3 by 2 means cos n pi x upon l. When we put l equal to 3 by 2, this 2 will go to the numerator, and we have cos 2n pi x upon l plus summation n equal to 1 to infinity bn. L means 3, here we have 3, bn sine 2n pi x upon 3. And suppose this is the equation number 1. Here a0, an and vn are Euler's coefficient, and which we have to calculate with the help of given Euler's coefficient formula. Here formula of a0 is 1 upon L 0 to 2L f of x dx, that is 1 upon L. 1 upon L means 1 upon 3 by 2 means 2 upon 3. It is 0 to 3, and here we have 2x minus x square dx. Okay, now we have to integrate this. 2 upon 3, integration of this 2x square upon 2 minus x cube upon 3, limit is 0 to 3. This 2 is cancelled out, that is 2 upon 3. Here we have 9 minus, here we have what we have here, 9 minus 27 upon 3, and that is 0. Here value of a0 is 0. Next we find out an. Formula of an is 1 upon L 0 to 2L fx cos n pi x upon L, n pi x upon L dx. But here L is equal to 3 by 2. When we put L equal to 3 by 2, here we have 2 by 3, and L equal to 3 by 2 means here we have 0 to 3. Here fx is given 2x minus x square, and when we put L equal to 3 by 2, the 3 by 2 means that 2 will be go to the numerator term. Here we have 2n pi x, that is cos 2n pi x upon 3 dx, that is n equal to 2 upon 3. Now we integrate by parts, taking 2x minus x square as a first function and cos 2n pi x upon 3 as the second function. Now first function means 2x minus x square as it is, integration of second. Integration of this term is integration of cos is sine, but here when we differentiate this bracket term, we get here 3 upon 2n pi into sine, integration of this sine 2n pi x upon 3. Integration of cos is sine, minus differentiation of first, this term. Differentiation of first is 2 minus 2x. Integration of second. Integration of sine is minus cos, means it is minus 3 upon 4 minus 3 upon 4 n square pi square and cos 2n pi x upon 3 plus differentiation of first term, that is minus 2, integration of second, that is minus 27 upon 8 n q pi q into integration of this sine 2n pi x upon 3. And limit is 0 to 3. Now we apply the limit. 2 upon 3 is the common term. Now see here, when we put x equal to 3, okay, when we put x equal to 3, here we have 6 minus 9, but when we put x equal to 3, means this 3 will be cancelled out. Here we have sine 2n pi, and we know that sine 2n pi is 0. Sine 2n pi is 0, means we get first term is equal to 0 when we put x equal to 3. Now what about second term? When we put x equal to 3, the first term will be 0. Now we solve second term. This minus and this minus will be plus. Now here we have 2 minus 6. Here we have 9 upon 4 n square pi square into, when we put x equal to 3, cos 2n pi. Cos 2n pi means minus 1 to the power 2n. That is minus 1 to the power even number means plus 1. Cos 2n pi is equal to plus 1. Here we write this equal to plus 1. Then again we have, when we put x equal to this term 3, here we can solve this minus and this minus is plus, and here we have sine term. When we put x equal to 3 cancel out, means sine 2n pi, and again we know that sine 2n pi is 0. Sine 2n pi is 0, means this term will be 0. Now minus lower limit, when we put x equal to 0, means this complete term will be 0. First term 0. Here minus minus plus, when we put x equal to 0, here we get one term. Okay. Now when we put x equal to 0, what we get here? When we put x is equal to 0, here we get zero minus minus plus 2 into 9 upon 4 square, and cos 0 is 1 into 1, and next term is, when we put x equal to 0 here, means sine 0 is 0, means next term will be 0, means we can write here plus 0. Okay. Now see here, n equal to 2 upon 3 is the common term. Here we have 4. 2 minus 6 is minus 4, means minus 4 into 9 upon 4 n square pi square, and here we have minus 9 upon 4 pi square n square into 2. Now this 2 is cancel out, this 4 is cancel out. Okay. Now we solve this, that is 2 upon 3. Here we have minus 9 upon n square pi square, and here we have Here we have n is 9. Suppose this is not cancel out. Suppose here 4 pi square and n square is common term, or we can say suppose this 4 is cancel out, means here we have 9 upon 2 pi square n square, that is 2 by 3. Here 2 pi square n square is the common term. Okay, here we have minus 18 minus 9. On solving this, 2 upon 3 into minus 27 upon 2 pi square n square, this 2 will be cancel out, means an is equal to minus 9 upon 3 1 ja 3, 3 9 ja 27, minus 9 upon pi square n square. This is the value of second Euler's coefficient an. Now we find out next Euler's coefficient bn. Okay. Now next Euler, now we calculate bn, and we know that formula of bn is equal to 1 upon L 0 to 2L fx sine n pi x upon L dx. But here L equal to, we have L equal to 3 by 2. Okay, so when we put L equal to 3 by 2, means we have here bn equal to, when we put L equal to 3 by 2, it will be 2 by 3, and limit will be 0 to 3. When we put L equal to 3 by 2, 2 cancel out. And what is fx? Fx is given 2x minus x square, and here sine, when we put L equal to 3 by 2, it will be sine 2n pi x upon 3. Here we have sine 2n pi x upon 3 dx. Now again we integrate by parts, taking this as a first function and this as a second function. Now what will be bn? Bn equal to 2 upon 3. Now we integrate this function. First function means 2x minus x square. Integration of second, we know that integration of sine is minus cos. Okay, and we have this bracket term, we have to differentiate this, means this will be 3 upon 2n pi, and differentiation of sine is minus cos, we have negative term, that is into cos 2n pi x upon 3, okay, minus differentiation of first. Differentiation of first means 2 minus 2x. Integration of second. Integration of second means here we have minus 9 upon 4n square pi square, and integration of this cosine is sine 2n pi x upon 3. Okay, plus minus alternate, then plus sign. Differentiation of this term, differentiation of this term is minus 2. Okay, and integration of this term, integration of this term means minus 27 upon 8 n cube pi cube, and integration of this sign is minus cosine, so this minus will be plus sign, and here we have cos 2n pi x upon 3. and we close this integration, and this is the final square bracket, and limit is 0 to 3. Now we simplify inner terms. Okay, now we apply the limits. Here upper limit is x equal to 3. Now first we apply upper limit. Upper limit is x equal to 3, that is 3 into 6, 3 into 2, 3 into 2 minus 9. When we put x equal to 3, it is 6 minus 9, minus is the common term, okay, into 3 upon 2n pi, and here x equal to 3, this 3 will be cancelled out and cos 2n pi, and value of cos 2n pi is minus 1 to the power 2n minus 1 to the power even number means plus 1. So means this term is plus 1. Okay. Now we this minus and this minus, we have common plus sign. Okay. Now when we put x equal to 3, here we have sine term. Sine term means this complete term will be 0. Sine 2n pi is 0, means 0 into everything 0, means second term will be 0. Minus, when we put x equal to 3 here, when we put x equal to 3 here we have minus 2 into 27 upon 8 n cube pi cube into cos 2n pi. Cos 2n pi is 1, minus lower limit x equal to 0. X equal to 0 means first term will be 0, minus minus plus, here sine 0 is 0, second term will be 0, and minus, when x equal to 0, here we get minus 2 into 27 upon 8 n cube pi cube, and cos 0 is 1. We get this term only. That is Vn equal to 2 by 3. Now solving this, here we have 6 minus 9, that is minus 3. 6 minus 9 minus 3, minus 20 into minus sign, plus 3 into 3, 9. That is 9 upon 2n pi. Here we have minus 54 upon 8 n q and pi q n to the power, this is n to the power 3, and this minus and this minus plus, we have 54 upon 8 n cube and pi cube. Now these two will be cancelled out, that is Vn equal to 2 by 3 into 9 upon 2n pi. This 2 will be cancelled out, this 3 3 is 9, means Vn equal to 3 upon n pi. Okay. Now from equation 1, what we have from equation 1? Here we have to put values of A0, An and Vn in equation 1. Now from equation 1, what is the value of A0? What is the equation 1? 2x minus x square. 2x minus x square is equal to A0 by 2 plus summation n equal to 1 to infinity an cos 2n pi x upon 3 plus summation n equal to 1 to infinity bn sine 2n pi x upon 3. That is 2x minus x square is equal to a0 by 2. What is the value of a0? Here a0 equal to 0 and an equal to minus 9 upon pi n square. Now we substitute these two value here. Here we have 0 plus summation n equal to 1 to infinity an. An means minus 9 upon pi square n square and cos 2n pi x upon 3 plus summation n equal to 1 to infinity bn. Bn is 3 upon n pi sine 2n pi x upon 3. Now simplifying this, that is 2x minus x square is equal to minus 9 upon pi square is the common term. Summation n equal to 1 to infinity 1 upon n square cos 2n pi x upon 3, and here we have what is the common term? Here 3 upon pi is the common term, and here we have summation n equal to 1 to infinity 1 upon n, and this is sine 2n pi x upon 3, which is the final answer. I think this method is clear to all of you. For this interval c less than equal to x less than equal to c plus 12, if you have any queries regarding this method, then you can comment on comment box, and if you feel this lecture is useful for you, then please like and subscribe this channel, and also don't forget to press the bell icon for getting notification about my lectures. Okay, thank you very much. Have a nice day, and Bharat Mata ki Jai.